Viitorul e al tău, noi punem temelia. UTCP, construim pentru România. UTCP, Universitatea de Construcții București.
Thank you so much, Loretta. It was a very long day with a lot of very interesting questions. Fortunately, I'm coming from Cluj, and as Professor Văgăreanu said, we are from a very low seismic area, so I'm safe. But I will start thinking about coming to Bucharest. So, I have 13 questions. I hope that 13, yeah? So I hope that it's not an unlucky number. Unfortunately, I will not be able to address all of them, so I will select some of them, and I think that the people who ask the questions are in the room, so they still can discuss a little bit after. So the first one is for Professor Batali, and the question is, are there ways in the new code to measure, test the improvement degree or other parameters to diffuse improvement in geotechnical structures?
Yes. Is this working? Yeah. I'm not sure that the part 2 of Eurocode 7 is addressing especially this, but I think there are in part 3 for the subclause on ground improvement some remarks, let's say, but don't expect to find the whole solution, let's say. And I think that we should adapt the testing methods to the kind of ground improvement that we are applying, and also to the percentages of binder that we are adding, because depending on this, we can have completely different values. So there is something, but probably not everything that you should need.
Thank you. The other questions were about Romanian norms as they are aligned with Eurocode 7, but you answered during the presentation they will be in the future. There is a start for everything. So the next question is for Professor Gazetas. And the question is, what factors are considered in the new Eurocode when assessing the influence of piles on the kinematic response? What factors are considered in the new Eurocode when assessing the influence of piles on the kinematic response?
There is no factor mentioned. It's only suggesting, it is a suggested code. You should take it into account. Period. That's why I presented at the beginning the physics of this problem to know what you should be able to do. The code does not say anything about it. I wish we could say they have the stiffnesses for the piles, for the inertial response, but for kinematic interactions, suggest you use the Beamon-Winkler Foundation model, one thing, for finite element, or go to the literature to find how much a decrease in the effective input motion would take place during an effort. There's no specific other thing.
And because you are in Bucharest, I have another question for you.
Please.
So the second question is it proper to evaluate the dynamic rotation stiffness of the foundation using the static soil parameters? Because what if we don't have dynamic soil parameters? Hard question.
The static soil parameters, well, for laterally loaded piles, which at the top, they produce a lot of strain, okay? The elastic using the VS or Gmax parameters are inappropriate. You should not use for a laterally loaded pile what we get for soil amplification studies. You have to use a nonlinear, much reduced, by at least a factor of 10 compared to the Gmax value. If this is what exactly that question meant, is it?
I hope so.
Yeah. But so the static values have to use static or dynamic values, because with the spectrum at 1.5 seconds, let's say, or 1.8 seconds period for Bucharest, this is almost, for the piles, almost a static loading. It's not a very dynamic loading for the piles. It's very severe for the structure, but at the end of the day, at the piles, it's a static loading. It's very high wavelength. And very high wavelength means that the piles will deform more or less like the soil. So, I know, I'm not sure I answered exactly what you meant, but anyway.
Thank you so much,
Yes.
Professor Gazetas. I have another question for Professor Văcăreanu, asking about liquefaction phenomena recorded during 97 earthquake in Bucharest. Do you know about? Well, here it's a question for Mr. Văcăreanu. There are some liquefaction phenomena recorded during 1977 earthquake in Bucharest. So sorry.
Yeah. There are some evidences in Bucharest, starting with the earthquakes of the 19th century, liquefaction, but we don't have this phenomenon in P100, and most probably it will not be. The liquefaction potential. As far as I know, we have a methodology for landslides. We will improve them. The ministry will improve the methodology, will take into consideration, but I have no information code related to the liquefaction. Maybe Christy.
In Eurocode 8 Part 5.
Yeah.
There is a methodology for assessing the liquefaction potential.
There are instructions, but then there is an annex where there is a detailed procedure.
I see.
Okay, and because you are here, I have a common question for you and Professor Pitilakis. Is it possible to establish a correlation between P seismic waves and CPTU parameters?
Wow.
Very so related.
Yeah, never heard of. Never think about this. Yeah, I have to see. Maybe he has have some
There are a lot of correlations. Now, it is very well said by the lady, I don't remember the name, that the quality of the measurements is extremely important. And it is not, let's say, simple to say that all measurements have the same quality properties. So, okay, there are some that we are using. We have more confidence to this because of the names, because of whatever, because of our own experience or expert felicitation, as I say. And that's all. We cannot solve the problem from A to Z, in my opinion.
So it's a very difficult task to establish a correct one.
It will be never solved. It's very important to have good engineers in order to make the best, let's say, exploitation of what they have.
And very good people on site who are doing the tests.
And of course, and the workers are very important. It's extremely important how they are living, for example, the way to fall from a specific and what equipment they are using, etc. There are a lot of things like that.
Civil engineering is not mathematics.
Yeah.
It's both mathematics and practice.
And common sense, I would say. I have another question for Professor Văcăreanu. Maximum magnitude considered in analysis, is it the maximum credible for Vrancea source?
So we have two different values, 8.1 and 8.2 moment magnitude for Vrancea, and there is a branch in the logic tree for Vrancea. We put more weight, so we consider 8.1 more likely to be the maximum considered earthquake, but it's the maximum considered earthquake. It's not the maximum earthquake Vrancea might generate. So there are some algorithms, some statistical algorithms you can use in setting up this maximum considered earthquake. As far as I remember, we used 3 methods. Some of the methods pointed to 8.1 something, some of the methods almost 8.2. This is why we consider 8.1 and 8.2 as well. But there is not that much difference in the result of them. seismic hazard analysis, because these very, very large frequencies come together with very, very low probabilities. So when you are aggregating together, then of course you have very, very large magnitude, and the aggregation of the seismic hazard shows that most of the seismic hazard from Vrancea is coming from magnitude 7.4, 7.6, 7.7, something like this. But of course, once you consider a larger magnitude with the seismicity in Gutenberg relation, you have more input. But the probability is very low.
Thank you so much. I have another question for Professor Arion. Is there a general accepted equation for the evaluation of the subgrade coefficient based on SPT-N value?
Regarding the SPT, as Professor Pitaki said, like everybody said, SPT is very difficult to be performed. And I noticed, like in many other cases, if I bring 3 companies to make a test, I will get 3 different results. Of course, we have many results, many equations from the United States since they implemented the method in 1930. And Japanese also. But we have to take into consideration our experience here of the company performing the test. After that, of course, we can look for the equations. Some of them are okay. As I show, we test and are good.
Thank you so much. I'm quite sure that there are more than these questions. Those are probably the main ones. And at least for me, it was a very strong geotechnical and earthquake engineering lesson today. So I'm wondering if the presentations will be shared with us, because they are a very good material to study at home later. So thank you so much. Loretta, please have the floor.
Thank you. I will ask all the speakers if they agree to disseminate the presentation, and if I have a positive answer, of course I will do it. And also please note that this whole seminar was recorded, and it will be on YouTube in some days, let's say. I have another question there, and then Professor Pitilakis will have a remark.
I have a question for Professor Hellenic. Let's suppose we have to calculate some stability or so. And in Romania, most of the designers, they just use the pseudostatic method. I mean, they just put a coefficient of horizontal.
Okay.
And my question is, how far or how close do you think we are from the reality using this method?
No, using the pseudostatic method to determine the critical acceleration, okay, is one thing, but it can take twice as much acceleration with a deformation of a few centimeters. In most slopes, you don't care, you consider it perfect. So we can reach factors of safety.
Yes, I forgot to tell you something else. And the stiffness of the soil is taken 3 times, about 3 times the static values.
No, this is a mistake.
This is a mistake, yeah.
This has been considered, these 3 times, which may occur sometimes, by people performing dynamic impact test. And the dynamic impact test, of course, it is Gmax. If you do a static test of this, it is much larger deformation. So it is not dynamic versus static, it's very small strain versus large strain. So it may work for another reason, because for some earthquake loading, maybe the strains are small. In some static problems, the strains are larger, like in bearing capacity type of failure. We're talking about large strains. 1, 2, 3% is what is the failure. In seismic, we're talking about 0.01%, much smaller space. So this tree is a misconception. At least it is used blindly. Now to the other question now, the slope stability. The pseudostatic analysis is very conservative. We can exceed the critical acceleration by a large amount, by a factor of 2 or even 3, without much damage. That's why we go to these McDician or Ambrosius and Sarma curves, which say that for essentially a factor of safety much less than 1, not just a little bit, much less than 1, 0.5, 0.3, the consequences for the slope may not be disastrous. It's not a failure, it's a deformation. If you have a slope that even 2 centimeters is extreme because you have, let's say, a museum on top of it or sensitive structure, yes, maybe you should be limited to the critical pseudostatic acceleration. The same thing applies to the footings. We can have accelerations and forces which produce dynamically bearing capacity failures. But this will not last for a long time. And there is a back and forth rotation which makes the outcome quite acceptable. So I don't know if I answered properly.
Yes, but in this case, the designers have a big problem.
Yeah.
Because we have to work somehow in the code, in the standards, because you never reach some satisfying values. So you have failure most of the time.
The already existing Eurocode, Eurocode 7, for slopes and retaining walls, had already the factor of 0.5. Indirectly, it didn't say you can have a factor so much lower than 1, people will be scared. It says you divide the acceleration by 2, which is the same thing, to do the pseudostatic analysis.
It's a small, could be smaller, I think.
Could be smaller, of course. That is this high or he. You call it he or kai? We call it he. He. That's very good. That's nice. Okay. This key factor is precisely this. You don't decide with the acceleration, but you divide the effective acceleration with a factor which will be even up to 3, according to the code.
Yeah. So this should
Yes.
be something added to the standard.
Otherwise, if you use the time history analysis, the dynamic analysis, whatever you find, you don't consider factors of safety, you find the displacements. Are they acceptable or not?
Yes. Yeah,
Thank you.
Thank you. It's a very bad news for the designers that thing about 3 times the statical modulus, which is widely used.
No, they do it already in the past code.
No, but the first question, I mean.
The
First question,
yeah.
the 3 times the static.
The 3 times, it can be the case if you're talking about very small deformations, dynamic deformations. Yes, of course. No, 3, 10 times more. It is a function of frequency, the G versus gamma curves. So this is the reality. Unless you have some sensitive soils which are dependent on the frequency of the load. But we're talking about very sensitive, extreme case, and extremely high speeds, which is not happening in earthquakes. Not in Romania.
No.
The dangerous ones. I'm not considering the other, as you know.
Yes, I have a couple of remarks starting from the very recent one. Eurocode 8, the part 5, has a rather different philosophy on the flow stability. It's not the pseudostatic approach. It more or less says that what is important is the deformation, and not the deformations like this, the permanent. So it is proposed how to estimate. Of course, there are different methods. So we are proposing a number of methods which are more or less updated. And in the United States as well, there is a kind of thinking and process now, how, and it has been presented in the last international conference of earthquake engineering, how we could estimate the permanent deformations after an earthquake in a specific slope. So this is the direction. Eurocode is in this direction, proposing a number of different methods, let's say, or models. But the method is this. I have the possibility of having 2 centimeters. I will design with this one. I have the permission of 5 centimeters. I will design with this one. The critical acceleration that has been said by Professor Gazetas is along this line. So this is the whole methodology. The second comment is regarding the famous VS30. It is sometimes a misunderstanding about what is the VS30. VS30 has been proposed by a UAGS engineer. The name is Boscher. Just because most of the geotechnical surveys were of 30 meters. And so he started with this saying that everywhere in the world they are doing at least 30 meters. So I'm suggesting a VS for the majority, let's say, the 99%. It is not a measure of how the amplification is at the first 30 meters. It may be much higher for the 10 meters, or for the 5 meters, or for the 60 meters, depending on the soil stratification and the soil profile. So we have to see the VS30 as a simplification of the nature in order to be able to speak between us. Of course, little by little, it has been extended in a much larger, and it may be very misunderstanding in many cases. And for this reason, in Eurocode 8, in the new one, we made special attention to this. Because if you have 5 meters depth, and then you have with an impedance of 4 between the 5 meters and below, you say the 30 meters VS means nothing. Nothing at all. So we must be very careful how we are using the VS30. The third point is regarding more or less your case here in Bucharest. In my opinion, it is very important to start working with the array measurements of microtremors, meaning a number of stations in very big diameters, I mean, let's say 100 and more, in order to be able, with ambient noise or with some forced vibration, to go deep. In my opinion, it will be probably the best way here in Bucharest to estimate what has been already said. It is 70 meters, it is 100 meters, it is 300 meters, how deep it is. And it seems that still now, with exception of 1,200 meters that I have seen, which is more or less the crystalline or more or less this, I believe that it is not necessary. We have discussed a lot with George. What is the meaning of VS 800? It means practically nothing. If you have the contrast, which is strong enough for 600, you may use this one, but we have to give a number. And in my opinion, these deep array measurements, it may be the best solution. Not the mass system. I agree entirely with Christian that it is not the best way to estimate because it introduces a lot of uncertainties and we cannot control it. And I would like to, let's say, to complete my modest presentation here about something that I try to, during all this nice presentation, with the exception of the ones of this afternoon, which are more technical, to say what we are doing with the Eurocode. And if I were extraterrestrial and I was coming here, I would say these people are crazy. Really crazy. Because they are complicated their lives in a way that they try to solve the problem of the uncertainties, introducing a huge complexity everywhere. And they forget that in the application of a civil engineer, we are introducing, through the methodology, not the hazard, but the epistemic, enough uncertainties on top of all this. I am afraid that with the Eurocodes as they are now, probably the uncertainties that will be introduced by the misapplication, the non-correct application of what we are proposing, it will be very, very important in practice. I don't know how we will solve this. And I was trying during the presentation to find a solution. I would say, why, for example, having so many partial factors? 1.1, 1.2, 1.3, 1.4, 1.5, all this. I couldn't find a solution about this. And I said to myself, probably the only solution should be go from, let's say, the end of the whole process. Say, I pay much more money for the construction, having the same safety, let's say, with 1.1 or with 1.4. I think, and probably you know, or you as well, which is the impact from economical point of view to the structure of introducing a variation of the different factors that we are proposing. Maybe at the end, for the ordinary structures, it will not be so important. Maybe, I'm not sure, that I am using 1.1 and not 1.5. Maybe the difference will be so small at the end that probably it is not a big deal to spend money and brain and whatever in order to be sure that if I propose 1.1 or 1.5, and I'm not speaking only for the geotechnical, I mean for us as well, for everything, it's so important. We have to do this, let's say, money, excuse me for the word, but economic impact of what we are proposing for the structures. Maybe it is a suggestion quite quick here, when I heard all our presentations, which are very complicated. So sorry of creating this mess with the Eurocodes, but I believe that we have somehow to think about what we are doing at the end.
We are discussing that indeed things are much more complicated at every revision, and we don't know if it is on the right side, let's say. And I think that for us, at least, for Eurocode 7, probably also for Eurocode 8, we should involve many engineers here in Romania in order to prepare whatever decision we will take for the MDPs. Because you remember, Professor Mana is here, after the first generation, once that it was, 7 years took to apply it, but also we faced huge sizing of footings and so on, and we are not always very sure that this is really required. So my message, and I think it is according to yours, is we cannot influence anymore what is happening at European level, because now it's almost done, and we are kind of pioneers of this system, at least in Romania. And we have here a representative from the ministry. Maybe we can do something in order to prepare ourselves for the future national annexes, because this will come very, very fast, and we will
face a decision, a fast decision, if we are taking 1.3 or 1.5. And when we don't have a basis for this decision, we are taking 1.5. Because this is the conservative side. Yeah? So if we are not doing this, we will face again a massive increase of the cost, size, and everything in our buildings. Professor Gazetas would like to address a question to Annabella.
Annabella,
She's coming.
it's all right. Fantastic presentation. Just a small question. The accelerations you determined at a great depth of 1,000 meters, why they were so much higher? Is it because the model brought them down like this? What was the reason?
150 meters or at the base?
At the base, yes.
At
At bedrock. The other one was very clearly understood, but why at the bedrock was so high?
At the accelerations from seen from the stochastic method. The stochastic method has the characteristics of source and then the characteristics of bed. So at the bedrock, these two characteristics generated the PGs.
Thank you very much.
Thank you, all of you, all the speakers, all the answers, those who answered to the questions and so on. I think it was a very long day and dense seminar. And as Nicoleta was saying also, we learned a lot, and I hope it was useful for all of you. I think Mihalis Vardanis would like to do something now at the end of the seminar, so I am giving him the floor for this, and after that we will conclude our event.
Dear Loretta, thank you very much. I will thank myself, all the speakers for today's seminar. We indeed learned a lot today, and through the video recordings we will comprehend even more as we go through them. Thank you again very much. It was a full day, a very dense day, and I will proceed with some formalities to express our gratitude to our hosts today. And the first one goes to Professor Vakareanu, the rector of UTCB, for hosting today's event. And I will present you with a plaque from our society for your efforts today in organizing this event. Thank you very much for everything. Thank you very much. Thank you. And of course, last but not least, to Professor Batali for all her efforts and the organization of this event. She has been the heart and soul of this event so far. We will hope that she will help us along with the event that we are going to have in Greece. And again, I would like to present you with a plaque honoring your efforts and the organization that you have done for us today.
Fix it well.
Okay.
Thank you.
Thank you very much for everything.
Thank you. So it's over now. So thank you all for your attendance, and I really hope. Oh, Radu. No?
Yeah, no, please, go ahead.
No, just wanted to tell you that I really hope that it was useful for you, and really a huge opportunity to have you both and the other colleagues from Greece here. Thank you very much for making the effort of coming and presenting these keynote lectures. Thank you.
Just want to add that I really very much look forward for today for many reasons. To see very good old friends, to share new knowledge, to share our joy of
engineering doesn't matter. And I think that, at least for me, it was a very, very rewarding day. And I very much like to extend my gratitude to colleagues from Greece who came here today, and of course to Loretta and my colleagues to organize all this event. And finally, one final word, because Professor Kitilakis said something that, okay, so you are an alien, you are coming, and I said, okay, you are complicating your life. Indeed, you are complicating your life. But think about Eurocodes or think about technical regulations, whatever, okay? We have capacity and we have demand, okay? With the demand, at least for earthquake engineering, we have some uncertainties, but we know how to harness the uncertainties, and we say, okay, the uncertainties are this much, but what about structural engineering? And Kyriazis mentioned that, well, these are the fragility curves, and we know very little about this. And this is true. So there is a lot of knowledge incorporated because there are a lot of projects, that were financed in terms of defining the action, but the classical civil engineering, the classical structural engineering was not financed for such a long time at the same pace. Okay? Because I have a very grim example. It's Pacific Earthquake Engineering Research. You know, it was in 20 years ago, 30 years ago, everything was coming from peer. Everything is coming from peer. Nothing else is coming from peer because nobody is financing peer anymore. And this is somehow very, very, very disappointed. And I think it is our mission to convey this message. Civil engineering is important. Earthquake engineering is important. Geotechnical engineering is important. And to get more good people with us. And events like today maybe will convince, looking at YouTube or whatever, to pursue a career in engineering. Thank you so much.
Viitorul e al tău, noi punem temelia.